Hello, AP Calculus students, to day 2 of our review of free response questions for the AP Calculus AB exam. I'll start off with a little bit of a warm-up, and then we'll get to the free response question itself. So here we have a multiple choice question. If the displacement from the origin of a particle moving along the x-axis is given by s is equal to 3 plus the quantity t minus 2 to the 4th power, then the number of times the particle reverses direction is blank. So first off, whenever we talk about displacement, if it helps you, just think of displacement as position. Okay, position displacement, almost the same thing. So we're asked to determine how many times does this particle reverse direction. So the way we're going to do that is we're going to determine how many times does the velocity change signs. How many times does the velocity change signs? And recall that the derivative of the position function, or in this case the displacement function, is the velocity function. So we're going to take the derivative of this equation. So if we take the derivative of this equation, we end up with 0, since the derivative of 3 is just 0. Plus, we got to use the power rule since we have an exponent there. 4 comes out in front. T minus 2 stays the same. The exponent is now 3 since we subtracted 1 from the exponent, times 1. Since we use the chain rule, we multiply by the derivative of the inside, and the derivative of the inside is just 1. All right. So we can rewrite this as 4 times the quantity t minus 2 cubed. All right. So that's our velocity function. Now, to determine whether it changes signs, we have to determine when it is equal to 0. Now, it should be pretty obvious since the only quantity we have inside of parentheses is t minus 2. If t minus 2 is set equal to 0, that means the only t value that would make this expression equal to 0 is 2. So we're going to put that on a number line, and we're going to test a value to the left of 2 and to the right of 2. So we're going to test these values into the velocities since we're trying to determine if the velocity changes signs. So we'll try v of 1. So if we plug in 1 into the equation for v, we get 1 minus 2, which is negative. If we cube it, it stays negative. Multiply by positive 4, and it remains negative. Now let's try a value greater than 2. So 3 minus 2 is positive. If we cube it, it's positive. If we multiply by 4, it is positive. So at 2, it indeed changes signs from negative to positive, which means the particle reverses direction. Since that's the only value where it does that, it means it's only one time where the particle reverses direction. So that's a little bit of a warm-up. Hopefully you tried it out yourselves before watching the explanation and the solution. So let's get to our free response question for the day. So in the previous lesson, we looked at the first free response question from the 2019 AP Calculus AB exam. Today we're going to look at the second question. So the second question is still calculator allowed, so we will be using a calculator in parts of this problem. So we're given a table. The velocity of a particle p moving along the x-axis is given by the differentiable function v sub p, where v sub p of t is measured in meters per hour and t is measured in hours. Selected values of v sub p of t are shown in the table above. Particle p is at the origin at time t is equal to 0. So this last sentence is actually going to be useful for us eventually. The fact that it's telling us where the starting point is. So this is the starting point, or the starting position. So starting position of P. Okay. Now, let's get to the first part A. So justify why there must be at least one time t for 0.3 less than or equal to t less than or equal to 2.8, at which v sub p prime of t, the acceleration of particle p, equals 0 meters per hour per hour. So that's our first question. Now the key word here is telling us why the derivative has to equal 0. The derivative has to equal 0. So there is a theorem that we talked about in class that talked about this idea that the derivative has to equal something. And the theorem was the mean value theorem. So the mean value theorem, if you ever want to look up more problems such as this one, the mean value theorem is what we're going to be using to answer this part of number 2. So the mean value theorem basically says that given a function that is continuous and differentiable, and we are told that in this problem our function is differentiable, there must exist some x value, in this case some t value, some x value such that the derivative of that x value at that x value is equal to the slope of the endpoints of the interval. So in this case, the endpoints of our interval would be 2.8 and 0.3. So that's what we're going to be doing. So let's do that. So let's find the slope first between those two endpoints. So let's find the slope first. So this is part A here. So we're doing v sub p of 2.8 minus v sub p of 0.3 all over 2.8 minus 0.3. So if we look at our table, v sub p of 2.8 is 55. V sub p of 0.3 is also 55, so minus 55 over 0.5. So right off the bat, you'll see that the slope between these 2 points is 0. So hence, we basically proved what we wanted to prove. So now we just got to make our conclusion. So first off, v sub p is differentiable because we're told in the problem, and thus continuous. If something is differentiable, it means it is continuous. So we can say, we can say by the mean value theorem, so MVT, there exists some t such that t is between 0.3 and 2.8, where v sub p prime of t is equal to 0. So that would basically be our answer. So the key parts here that you would need is this finding the slope and showing that it's equal to 0, and then just seeing that by the mean value theorem there exists some t value such that t is between 0.3 and 2.8, and the derivative at that t value is equal to 0. Typically, when you're using the mean value theorem, you do have to state the conditions as well. So to be safe, I would make sure you mention the fact that since the problem tells us it's differentiable, hence continuous, we can use the theorem. So that's part A, so mean value theorem. So part B. So look at part B now. So part B, use a trapezoidal sum with the 3 subintervals to approximate the value of that integral. So we're going to use trapezoids to approximate an area, in this case an integral. So we're given the subintervals. So first recall that the area of a trapezoid, so area of a trapezoid is equal to base 1 plus base 2 divided by 2 times the height. So that's the formula we're going to be using for our 3 trapezoids. So the integral from 0 to 2.8 of v sub p of t dt is equal to, so our first trapezoid, so recall that the heights of each of these trapezoids, are going to be determined by whatever the lengths of each of the intervals are. So the first interval is from 0 to 0.3, so the first height is 0.3. The second interval is from 0.3 to 1.7, so the second height is 1.4. And then the third interval is 1.7 to 2.8, so the third height is 1.1. So those are our heights. Our bases are going to be determined by the v values. So for the first trapezoid, base 1 is 0, base 2 is 55. So let's see what we got here. So for the first trapezoid, we have 0 plus 55 divided by 2 times 0.3, since that's our height. So for the second trapezoid, our bases are 55 and negative 29. So we got 55 and negative 29 divided by 2. And the height this time is 1.4. And then our third trapezoid, our bases are negative 29 and 55. So negative 29, 55 divided by 2, and then our height is 1.1. So if you once you calculate this, you should get an answer of 40.75 meters. So 40.75 meters. So you just plug that into a calculator, and that's what you get. So that's part B. Excuse me. So now let's look at part C. All right. So now we're given a second particle, Q, also moves along the x-axis so that its velocity between 0 and 4 is given by the following equation, meters per hour. Find the time interval during which the velocity of particle Q is at least 60 meters per hour. And then find the distance traveled by particle Q during the interval when the velocity of particle Q is at least 60 meters per hour. So we actually have two questions here. First question, find the time interval when the velocity is at least 60 meters per hour. So that's our first question. So we're trying to find when the velocity of particle Q is at least 60 meters per hour. So I wrote it as greater than or equal to 60. So the way we're going to do this, since this is a calculator question and a graphing calculator question more specifically, what we're going to do is we're going to graph this equation. So we're going to graph this V equation of Q. So 45 times square root of T cosine. So take out your graphing calculator and we're going to graph it. So if I take out, and you should get a graph that looks like this. So you should get a graph. Let me actually fix that so you don't see. All right, cool. Oh, there's another one. Oh, here we go. There you go. All right. So you should get a graph that looks like this. So the purple graph is the graph of the V of Q equation. So now that's the first thing. Second thing, I also want you to graph 60. So literally just plug in 60 as your equation. So just 60. So y is equal to 60. And you're going to get this black line. Now, the reason why we want to graph 60 as well is because we're trying to figure out when is this graph above this line. So the only part we really care about is this hill of the curve that we see here. Now, more specifically, we have to figure out what these two intersection points are because that's going to give us our interval. Now, any graphing calculator has the capability of finding the intersection. Now, it depends on the calculator. In this calculator, there's an analyze graph section, and you just find the intersection here. So typically on most graphs, you pick an interval. So I'm picking an interval here, and bam. So our first intersection point is 1.866. So 1.866. So let's write that down. So 1.866. And our second intersection point, so we're going to use the same thing. Second intersection point, we put that there, and zoom in. So there you go. Our second intersection point is 3.519. And on the AP exam, you always want to make sure you round to at least 3 decimal places. You can write down more decimal places if you want to, but you do got to make sure it is correct to at least 3 decimal places. It could be 4, it could be 5, at least 3. So that's our interval. That's the first part of the question. We're done. Second part of the question. Find the distance traveled by the particle over this interval. All right. Distance traveled. Now, there's a special formula that we use whenever we want to find the distance traveled by a particle. So you want to take the integral. You want to take the integral of the velocity, but you want to do the absolute value of the velocity. So the absolute value of the velocity. Now, the reason why it's absolute value. So recall that since velocity can be positive or negative, we take the absolute value because any negative parts we want positive. And the reason why, think of it this way. If I travel forward 5 feet, but then I travel backwards 5 feet, even though I ended up in the same place that I started, I still would have traveled 10 feet total, right? 5 feet forward, 5 feet backwards. If we put the absolute value bars, we ensure that we don't cancel out those distances, but we're actually taking into account even traveling backwards. So instead of saying that I traveled 0 feet because I ended up in the same place that I started, we would say I traveled 10 feet because I went forwards 5 feet and I went backwards 5 feet. So that's why we put that absolute value bar there. So we're going to do the the integral of the absolute value of v sub q dt from 1.866 to 3.519. So once again, this is something that you would just plug into a calculator. So if I get out this calculator app here, and you would have seen that I already did it. Depending on the calculator, once again, on some calculators, as long as you know where you're looking, there's actually an integral button. In this calculator app, it just shows you an integral. In other calculators, for example, on some of the 83s and the 84s, there is an integral function, but then you have to learn the format in which you have to input the equations. I'll make a video for those who have TI 83s and 84s that can help you out being able to evaluate an integral inside a calculator. If you have a calculator such as this, it ends up being pretty straightforward since it's literally just an integral button. So you'll see, so we did the integral from 1.866 to 3.519. Put the absolute value bars there, put the equation there, you get 106.109. So it traveled 106.109 meters over that time interval. So that's the total distance traveled, So now let's look at D. So the last one here, so D. So at time t is equal to 0, the particle Q is at position x is equal to negative 90. So that is the starting position of Q. Remember we made note earlier in the problem what the starting position of P is. This is the starting position of Q. And this is where we're actually going to be using that information in the problem. So starting position of Q. So it says use the result from part B, so that's when we did the trapezoids, and the function v sub q from part C, approximate the distance between the particles, so the distance between the particles. So what we're going to do is we're going to find the position of particle P, position of particle P and the position of particle Q, and then just subtract those two positions. So position of particle P is going to be 0 because that's where it starts, right? In the problem it said it starts at 0. And then the part B tells us that from 0 to 2.8, it goes positive 40.75 meters. So it looks like the position of particle P is 40.75 meters. And note, I say position this time, not distance traveled. It's the position. Because remember, we're traveling along the x-axis, so that's where it is on the x-axis. So now if we do particle Q, so particle Q starts at negative 90, and then we have to figure out how much it moves from there. So we figure out how much it moves from there by doing the integral from 0 to 2.8 of v sub q dt. So you'll notice this time I did not do an absolute value because we're not trying to determine the total distance traveled this time like we did in C. This time we're just trying to figure out where particle Q is on the x-axis. So this time it actually does matter if we go back to that example that I used earlier. It does matter if I travel 5 feet forward and 5 feet backwards, it does matter that I ended up in the same spot. In part C, we were just trying to determine how much distance I traveled. In part D, we're actually trying to figure out where am I? Where is my position relative to where I started? Okay? So once again, we just plug that into a calculator. So you should get negative 90 plus. So once again, if we look into here, you just plug it into a calculator. If we see here, the integral from 0 to 2.8. And you should get 135.938. So 135 45.938. So if we just add those two, you end up with 45.938 meters. And once again, finally, we're trying to find the distance between these two particles. So 45.938 minus 40.75. So you should get an answer of 5.187 meters. So that is our final answer for D. That is the distance between the two particles. You'll see on this handout, I also attached the scoring rubric. So the scoring rubric is literally what is given to the people who grade the AP exams. So the people who grade the AP exam are literally given this, and they use this to determine how many points you scored for each question. So you'll see it breaks down. For example, in part A, you'd get 1 point just for showing that V sub P of 2.8 minus V sub P of 0.3 is equal to 0, and then another point using mean value theorem to show why it has to be true, so on and so forth. So hopefully you tried out the free response question before you watched the video. Otherwise, in terms of the next assignment, I want you to continue the handout from the previous lesson, so the one titled A Journey Through Calculus. So instead of doing page 1, I want you to do page 2. So I want you to do page 2 of that handout. It will be extra credit just like the previous one. So page 2 of that handout, A Journey Through Calculus. I believe it's another 4 to 5 problems. Otherwise, I hope this video went smoothly. Hopefully, it's making sense. Always let me know if you have any additional questions. I hope you guys are staying safe, and I hope you guys enjoy the rest of your days. See you later.